Okay, so we are going to be talking about Hess's Law today, and Hess's Law will also apply to the calorimetry lab that we're going to be doing tomorrow or Tuesday. So, first of all, when we talk about, we've been talking about enthalpy, kind of the heat of reaction, um, and when we measure the heat of a reaction, it's obvi often it's not super convenient or easy to measure the enthalpy of a reaction or the energy of a reaction, the heat given off or the heat absorbed. And so sometimes we might apply a different system to measure it. So sometimes we might estimate the heat of reaction or the enthalpy of a reaction using like published or values for enthalpy that you might find in a book related to different compounds that exist. So how this might come to be, or one way that we might apply it. So Hess's law is this idea that if a reaction is carried out in a series of steps, the delta H for the overall reaction will be equal to the sum of the enthalpy changes for the individual steps. Meaning, so let's say we have the combustion of methane with oxygen. Okay, so the combustion of methane is methane combining with oxygen, and the products are going to be carbon dioxide and water. But let's say we don't know delta H1, so that's unknown to us, so we can't actually solve for that. So what we can, maybe we can use literature values to find out, well, what the values of the production of carbon monoxide with water, so we know that delta H, and then we know the delta H when that combines with O2. So we can kind of have these in-between stages to get there. So we can use a variety of kind of workarounds to figure out what the enthalpy of a reaction that we're doing using values that are unknown. So, and this is really based on the fact that enthalpy is a state function, so it doesn't matter the path that's taken, but it's really, if we know the initial state and we know the final state of the products, we can, whatever path we take to determine the enthalpy, the final answer or the enthalpy will be the same no matter what. So what this will lead us to is the idea of enthalpies of formation, or the delta H, or the enthalpy. Delta H subscript F is enthalpy of formation, and it's defined as the enthalpy change for the reaction in which a compound is made from its constituent elements in their elemental form. So, meaning, so you have a table in the back of your book. You have this table on in chapter 5. Of a variety of delta H formations for a variety of substances, and this is based on at 25 degrees Celsius and 1 atmospheric pressure. So all these different compounds are formed at these different temperatures. So you can actually use the delta H of formation to calculate the enthalpy of a reaction just by taking all the component pieces. So an example being, so let's say we wanted to calculate the delta H of this reaction. So we know that, so we kind of break it up into these smaller pieces. So we want to go CH3, C8, so this is our reaction up at the top, CH3, H8, and combines with 5 oxygen to produce 3 carbon dioxides and 4 waters. Well, so we have to break up all the pieces individually. So the first one is, well, how would you, so in the end, we don't have the C3H8 anymore. So first of all, we're going to decompose that into graphite and hydrogen gas and figure out what the enthalpy of that would be. Okay, so we have that step. So it would take 103.85 kilojoules to go from that to this graphite plus 4 hydrogen gases. Okay, and next we look at the idea of, oh, well, what would it take to form those 3 carbon dioxides? Well, to form 3 carbon dioxides, you would be combining the carbon with oxygens to form the carbon dioxides. Okay, so then we can use the delta H of formations for those to then calculate it. And then the following step would be taking the the hydrogens which are there and combining those with two oxygens to get the energy associated with the formation of that water. And then if we kind of cancel things out, cross things out that are on both sides, um, we end up with the sum reaction, which is what we started with. And then we can take all the delta H's, okay, so delta H of products with delta H of reactants, and get the delta H of the reaction. So going here, we've got our different pieces there. Okay, you can kind of look at it there, and combine them together, and we get the delta H of that reaction. And we're going to practice these in class because it's kind of difficult to grasp them just through a PowerPoint slide.